So yeah.
No,
Oh, that's probably quite good.
it's all or nothing, isn't it?
It's actually probably good. It's all photos.
Yeah.
So
okay, great.
the better they show
Leave it
up.
as it is, unless you want to be in doubt.
Well, or is it all or nothing? Is that what you so yeah, I'm Hardwick's forest manager, woodland manager. Have been sort of since, well, I was first involved 2014, 2015. So yeah, and roughly this is going to be about why manage woodland. But I probably won't answer that question directly. Hopefully it'll be evident by the end of the presentation. And we're going to look at Hardwick as an example, but it's, woodlands aren't in isolation. You can never manage them on their own. So what's happening at Hardwick's very much happening in the Chilterns, and what's happening in the Chilterns, the same things apply to other woodlands in other parts of the country. So yeah, let's start.
Do you think we could have the lights on? Because it's.
Are you ready?
Give it a go. Yeah, it's all photos. So the more you can see of the photos, the
You
better.
see a lot more.
Yeah, good.
Cool.
Just didn't want to do it without.
This is great. You could all be asleep now. So yeah, I won't read all through that, but I'm going to go sort of back, talk a bit about glaciation, talk a bit like the last 300 years, 400 years of human history of the woods in Hardwick and the Chilterns, and why we essentially have so much beech of the same age. And then I'm going to take a focus on what's happened in the last 10 years, why it's happening, talk a lot about how we've been growing trees for the last 300 years, quite a bit of climate change all the way through, and then talking about continuous cover forestry or near natural woodland management. And I have to get the words in straight away, because other fellow colleagues would hate me if I didn't, but irregular high forest silviculture is really what we'll get into, but it should become apparent. So, all of the Chilterns and where we are here in a band, sort of going to Princess Risborough, was glaciated in the Neocene, so you can see the ice sheet coming down to us there. And as it melted, none of the colours have come up on that. That's a bit funny. That's a slightly close map. Let's go back. You can't see this either if it's too dark, but there's a 3D map here. Essentially, but as the glaciers are treated, the meltwater carved all of the dry valleys of the Chilterns. So all through the Chilterns, and you go up sort of High Wycombe and beyond, there's all these steep valleys with no rivers in the bottom, and they were all formed by the glacier retreating, all the meltwater rushing down, forming these valleys, and depositing various deposits of sand, silt and clay on the top of the hills. So it was weird for me to get my head around when I moved down here, coming from Scotland, where everything sort of glaciated the other way around. From the sort of top of the hills down, you have lots of erosion at the top of the hills and not much soil, and all the good soil at the bottom of the valleys. Whereas in the Chilterns, it's weirdly kind of the other way around, which is why, and we'll go through it in other maps, you have trees and crops of trees that need much better soils on the top of the valleys, and you've got these eroded valley sides with like lots of beech that can handle a really thin soil. The next map is actually a geology map, which for some reason the colours haven't come across, and it shows the deposits, but I'll have to skip over that. But essentially we've got really localised soil conditions, and at the top of the hills we've got deposits of clay which can take fantastic Douglas fir, and then ranging 30, 40, 50 feet that will drop off to other deposits, and quite quickly when you come off the top of the hills it will go to chalk. And on the chalk we've got a soil known as a Renzina soil, which is a sort of term for a soil without a B horizon. So there's very little interaction between the parent material and the top. Other than that, it's very high pH with a couple of inches of topsoil. And that becomes quite crucial when we go and start talking about squirrels and deer and climate change, because it's very limiting. Essentially on the slopes of the Chiltern soils, it's a very, very limiting soil in terms of what we can grow. So the history of the Chilterns really kind of goes back 300 years, and High Wycombe is right there, nestled And High Wycombe was to the timber industry and to furniture making what Sheffield was to steel. And within 100 kilometres of basically what was economical at the time with a horse and cart, for 250 years, the Chilterns, with its poor soils on the sides of its slope that weren't good for agriculture, they were put to growing beech trees. And it spanned a long time, and it's really dominated forestry practice in the Chilterns, to the point where we've just got lots and lots and lots of beech plantations, lots of which are on old ancient woodland sites. And I do have another slide somewhere about the breakdown of ancient woodland Hardwick. But essentially on Hardwick, the ancient woodland, in a way, the important part of the ancient woodlands is in the soil. The trees aren't ancient. There's remnants, what we call old growth features, so there might be the odd old growth tree that was left by foresters during each rotation. But now, you know, it's all beech plantations of the same age, from the same species. But it's quite fascinating. Actually, recently, High Wycombe's trying to sort of rebirth itself as a timber town again, which is worth looking into. So these are some old pictures out of the office. I think around about 1910, pre-First World War. I think I know where it is. But it shows that we've got old records. Hardwick had around about 18 full-time foresters at the time before the First World War. And this picture is actually really fascinating because it shows the practices that they were doing. Everything that's beech, essentially. All the conifer came later because all the conifer were on old fields that then got given up on. But all the beech was planted with a nurse crop of Scots pine. And you can see in this picture, this is probably sort of year 25, 30 after planting. They're coming along, they're taking out the Scots pine, and they're letting all the other trees grow on. But incredibly intensely managed. And it's phenomenal what they did over a short space of time. So Nooney Green, up behind the old King Charles pub, it's a 110-acre woodland, and that was completely cut over and replanted in a 10-year period by people like that. All hand planted, all hand cut, taken by horses. And it is amazing. We would struggle with all the modern machinery in the world to do the same today. So because of that intense period of 300 years of growing beech trees for High Wycombe, on Hardwick and across the Chilterns, this is very much a snapshot of the Chilterns, really. It's across the whole area, the whole AOND. We've got a breakdown of 50% conifer, 40% broadleaf, 85% broadleaf, sorry. And that, in a commercial, economic term, is really challenging, even in current markets, which are the best they've ever been for about 70, 80 years. But, and then of that broadleaf component, you can see 83% is beech. This is a little bit old. I made this slide 5 or 6 years ago. That ash is gone. It's all been cut down and replaced with a big mix, but you can see how Hardwick and the Chilterns is dominated by beech. And then we have the planting year. So again, going back, that period, lots of Hardwick is on its second or third rotation, which is essentially means crop. So the planting year of what we've got now is way down there, 1900, 1920. All of this stuff from 1980s, unfortunately, is dead because of squirrels, which we'll come on to. But there's a bit of a term in forestry called overstood. You know, a stand is overstood. And it's a bit funny, it doesn't really mean anything on the individual tree level, but it does mean something on the stand level. You know, you couldn't put it across to humans, you couldn't sort of call an 80-year-old person overstood. But you can talk about it in terms of an ageing population. And certainly with woodland management, if you think about risk, this is super risky. And obviously the slide before was talking about how it's all one species. So it's all one species and it's all really old. And it looks beautiful. it's what we know. It's what we think of as classically as the Chilterns. It's, you know, this time of year, in autumn the leaves are turning. It's a really, you know, they're really pretty woodlands. And there's a fascinating thing in the psychology of us humans that this is so old, this is generations old. And we think of it as a constant, really. But woodlands really need to change to be healthy. And in this picture you can see the single species, you can see the single age, and you can see how the canopies are quite small. They're heavily competing for light and resources. They're all grown really close together. And the forest floor, and this is an ancient woodland site, has no life at all. And the only thing that's growing is holly. And in this instance, it's sort of acting as not an invasive, but it's blocking everything. If there were to become light, the holly's blocking, sort of high forest growing trees from establishing and getting away. But yeah, and there's been quite a lot of studies into beech plantations and biodiversity, and they're really poor. Everybody thinks conifer plantations, we know that's bad, but this isn't that much better. It kind of looks prettier, but in terms of biodiversity, it's really, really not that much better. And there should be so much more going, particularly with an ancient woodland site. So we pretty much know that site has been wooded since the last ice age, and what's in that soil when it comes to sort of plant life and ground flora, it is phenomenal. If we can release it, if we can get it some light. And we've got a lot of it. These pictures are some drone pictures, and they look beyond Hardwick, and you can kind of see the glacier deposits of better soil, which is where the conifer is, with these little pockets of conifer. That's all Douglas fir on clay pockets. The rest, certainly through this valley, is quite challenging. Thin soils over chalk. And then looking the other way, just to illustrate the point, we've got more of it. All the same age, same species, one big monoculture really. And I've certainly found talking to the public in the south, it's really important, it's probably the biggest thing that I can try and communicate, is that these are man-made plantations. They're a lot prettier than the Sitka spruce on the side of the hill in Scotland, but they are in many ways the same thing. Okay, how many for time? I think I've got loads of time. We need to talk about the last 10 years. So we really do. In forestry, I can't remember, it's a crazy statistic. I can't remember off the top of my head, but there's been an enormous proliferation of pests and diseases affecting woodland. And sort of since the mid-90s, it's just snowballed, one thing after the other. And that's showing on Hardwick, and it's showing nationally. And on Hardwick, we've got this scenario. Ooh, can't quite see that. So in the last 10 years, we have ash dieback, which everyone knows about, which is the various different colours. But we've also had Phytophthora ramorum, which affects larch. And we've had a disease called Dothystroma, otherwise known as red band needlebite, that particularly affects Corsican pine, also affects Scots pine. That amounts, all those polygons on that map, to just under 30% of Hardwick's woodland. In the last decade, we have managed completely reactively, so just essentially trying to put out fires. And it's staggering because in 2014 I was involved in Hardwick, and the management plan at the time was really trying to get a handle on all this old beech, what we're going to do with it, how we're going to diversify, how we're going to get it light to the forest floor. And that was all completely shelved to deal with this. And this is the picture on Hardwick, and it's the picture nationally. There are, so many other diseases. That's just what's affecting the trees here. But there's a big outbreak now of IPS, eight-tooth spruce bark beetle in the southeast, which could potentially be enormous to the industry if it ever got out of its demarcation zone now. There's loads of other things, hundreds and hundreds and hundreds of things that, sort of in the 80s and 90s, foresters just weren't worried about. They weren't worried about this sort of huge amount of pest and disease. And so I would argue climate change is massively already having an impact. Trees are stressed, that's why they're succumbing to these diseases. Certainly things that I signed myself up with the school of thought that we had ash dieback in the country way before the official 2012. If you sort of read anecdotes from foresters' journals, there was a weird drought-related illness affecting ash, sort of late 90s, early 2000s. But what it's taken, and I don't have a slide, but if you kind of imagine it, you can picture it, you've probably all seen it. If you look at sort of drought events on a graph for the last 80 years, all of the last worst ones have been in the last 10, 15 years. So trees are stressed and other things come along. But there is another thing going on, which is what I will start talking about next, which is there something wrong with the way we've been growing trees? So all of Hardwick and all of forestry in the UK, current stats are 96% of UK woodland is managed on a often not single species, sometimes they're trying to use two species, but essentially even age plantations where trees are often planted 2 metres apart, they're grown really competitively, they're grown on, and they develop very small crowns. And the main thing that to stress with disease, the only way a tree has to fight disease is to produce carbohydrates by photosynthesizing. It doesn't really have anything else. And if it's got a tiny little crown and not much leaf or not much needles, it can't produce those carbohydrates. So if we're growing trees like this in this really stressed out manner, where they don't have their crowns and they're also really heavily competing for nutrients, we're in for trouble. And you add climate change onto the mix, and it's a recipe for disaster. And that's what's playing out with, like the slide before, the last 10 years. And ultimately, the biggest problem with this is it ends up, this is quite a dramatic photo for effect, in that sort of thing. And I mean, you don't have to be a genius to know why that's bad. And particularly in conifer, this is a conifer stand, you can see the bare mineral soil exposed. A machine would go through that in a day, couple of days, and all of a sudden ground that hasn't been exposed for 40 years is exposed to the rain, to leaching, and it's a disaster. So there's two things going on when we talk about continuous cover forestry. Continuous cover forestry essentially is avoiding this, but within continuous cover forestry, when I mentioned before, irregular high forest silviculture is trying to look at how we can grow trees in a woodland setting where they're grown healthily, with big crowns in a sort of near-natural manner. And to illustrate the point a little bit more, so these are both trees in Hardwick, and there's a study that confirms this that was done at Salford University involving a colleague of mine. So on Hardwick, the left-hand picture, that's all our ash, that was bottom wood. It just died within a few years, catastrophically. And this was all pull stage ash, from sort of 30 years old. And that ripped through all the way up to the older trees. And when we went around, we were working it for 4 or 5 years. We were always trying to mark trees and save trees that were showing any sign of resistance. And the big hope is that there would be some genetic resistance. And there is some genetic resistance, but usually they're in different parts of the country. Foresters over the last 300 years have never bothered to plant ash. It just grows prolifically. So you'll find in woodlands that there's not a big mix-up of genetic material because it's not been planted, it's not been picked up from somewhere and moved elsewhere. It's often all regenerated off the same trees. But yet that's the case. We still have fantastic ash trees on the estate. This is just above, when you go up the hill up behind Five Ways where the chalk cliff is, it's just above there. And there are a few, it's not very many. We've been desperately trying to keep them. What's fascinating about their history, and it's been confirmed by a study, is the difference between the tree on the right and the tree on the left is it's not been enclosed. It's not had a period of 30, 40 years in a plantation where it's all been hemmed in. And there was a big study done at Rushmore Estate where they looked at all the old maps, all the old data they could find, and laid across where they had trees that were showing lots of resistance, and they found that very thing. So it's proof, if we do really need it, that growing trees and open systems with big healthy crowns is ultimately good. And it's not just ash dieback. So all those diseases I mentioned before, they're all fungal pathogens. They all require spore loading. If you've got loads of trees all at the same height with no wind flow, they're all much more susceptible. As opposed to a woodland where you've got a huge, big, diverse mix of age ranges and a lot of diffuse light with wind coming through the stand. So enter irregular continuous cover. I quite like these photos because they say a lot. Foresters for 300 years, we've been really focused on hemming trees in, growing them like matchsticks, we have these things called yield class curves, which I was going to put a slide on. But it's essentially, people have worked out, you put a load of Scots pine together, and its growth curve does something like this. It goes roar, and then tails off. And then foresters have been fixated upon this point here, at which age, on what type of site, the growing rate of the tree tails off. And then we cut it all down at that point, and that maximises income. But nobody's ever thought that if you didn't grow trees all like this, and they were all essentially on one plane, sort of imagine it as 2D, and we grew trees, well, instead of lots of little ones that we all harvested at one time, we grow massive big things, and we lock up all the timber into huge, huge, huge trees. What do the growth rates of trees in that situation do? And finally, we're starting to get the data for that. There's a really fancy bit of 3D scanning, terrestrial scanning using X-rays, where they've been put in some developed stands of a regular continuous cover that every year they can monitor the input and the growth rate of all the different species up to 150 foot. And we're finding, lo and behold, that even trees that are 60, 70 years old, where conventional forestry would say they're too old, they're slowing down, cut them down, we're finding that if you isolate their crowns into the upper canopy of a mixed open woodland, they're growing like stink. They're still putting on timber. They're still growing. And that is what a regular continuous cover is about. Obviously you've got mix of age, mix of species, diffuse light coming through, always bits of the stand that will have light, rolling through the cycle every 8 years. Things will change. And roughly, depending on soils and species, that's what you're kind of looking to do every 8 years. And so instead of planting them all, thinning them all at 20 years, maybe thinning them again and then cutting them all down. Once it's developed, you're taking a big tree, probably 1 or 2 a hectare, every 8 years. And essentially, if you kind of picture what, I went to Canada and was thoroughly depressed about how bad the woodlands were. But if you imagine North America and you sort of think about what sort of naturally functioning woodland would look like, if you leave aside fires for now, the main natural disturbance is wind. So if we can develop a regular, near natural system, we can be the wind. And every 8 years we go and take, somewhat prematurely, but we go and take the big tree that maybe in 10 years' prior would fall with wind. And so long as we leave enough deadwood, so long as we're looking after all the functions of the forest, we can speed the cycle up, and you can have a forest with natural systems working, and you're still getting timber out of it, which is really important, which is the last slide. I would say that as a forester. So on Hardwick, if we've got our irregular, super diverse forest, if you can picture it in that last slide, how do we get our beech, our single species, single age beech plantations to that? And it involves cutting a lot of them down over phases, and I haven't got a slide on economics, but it's worth noting, a lot of people when they go into a woodland, they see trees cut down, they instantly think, oh, someone's making a lot of money. On Hardwick we've got a sort of rolling programme where we harvest and we turn over £150,000 a year, and we make a profit of roughly 8 to 15 grand, which is normally spent reinstating tracks. So, and that kind of goes back to that earlier comment about conifer. Because we've got such a small conifer element, which is dictated because we've got lots of chalk, it does make it kind of challenging. But it's a good thing to get out there. Hardwick is, very forward-thinking in its land management and isn't driven by money, and that really enables us to do this. There's a statistic, it's slightly improving, but about 8 years ago, 80% of the woodland in the southeast wasn't managed. And it actually goes back to something that I've slightly skipped over actually. One of the big reasons why the furniture industry collapsed, or in the 70s, or the furniture industry collapsed in the 70s, changes in people's buying habits with furniture, but that left this beech markets, they just went, over the space of a decade, they completely went. And it wasn't just in beech, generally the timber industry sort of took a big nosedive in the 70s and 80s, and it's only just recovering. There was a huge brain drain in the 70s and 80s. And so I've got a terrible cold by the way. Drinking a little bit of water. And so yeah, so there was a huge 40-50 year period where nothing happened. And going back into our beach, there's a lot of beach in Hardwick that hasn't been touched for 50 years. It hasn't been thinned, no one's done anything with it. Which in some ways is great, because when we come back to the modern day, we're going into our beach stands and we're trying to mix up their age and their species. What's really nice about them is that they haven't had big machines driving all over them. Pretty much every bit of conifer woodland in the UK now has had a 30 ton machine drive over it. And what that does to woodland soil structure is disastrous. But that hasn't happened on Hardwick through sort of bad reasons, but in a way it's exciting now, because if we apply ourselves and we do the absolute best practice, we can really minimise some of this damage. So I'm going to start talking a bit about permanent 30-metre extraction racks. But so you can see a tractor in that picture, and you can see the tracks going through the woodland. And these are what we call 30-metre permanent extraction racks, and they set up everything. They're not made up, there's no hardcore going on or anything, it's just where the machines will go. And kind of like how some modern farming practice is doing it, we GPS them. Most of the time, certainly if we do lots of underplanting or enrichment planting, which is what's happening in this picture, and it's what's happening in between these gaps. So we're cutting down the trees and we're using all of the money generated to do some of the planting, and then keeping a little bit so we can maintain that planting. And you can see the racks here, and there's another one there. There's another one coming up the side of this one here. And if we're clever, we can use modern things like LiDAR. I don't know if that's coming up very well. But Hardwick was quite lucky in a way. So the Beacons of the Past project came over and LiDAR'd Hardwick quite a while ago, and Nick Pankhurst, if he's here, gave me the files really quite early on. So we've been using them to place where the machines go and set up our permanent extraction network, so that we can avoid all of the archaeology. And there's so much archaeology in Hardwick's woodlands because there's been such an intense, not just the 300 years where we're talking about beach, but stuff before. And on this picture you can see through the old boundaries, you can see all these little pot marks, which are either borrow pits for flint or chalk pits, lots of old boundary marks. And so we can place our extraction racks so that we don't end up interfering with them too much. And the genius of it is, and it sounds a little bit like, talking about why the wheel is good, but somebody has to come and invent it. Knowing where your machine's going means that you can plant trees in a place where you're not going to trash them again in 8-15 years' time. And it's astounding how often that happens. There's various different places in the children's that I can point to where there's been a well-intentioned intervention to get some trees that aren't beech and are a bit younger into a hole, but they haven't done this, and they haven't looked at it on a big woodland scheme, and then 5, 10, 15 years later something else happens, ash dieback comes along, and somebody has to get a tractor from A to B, and there's all this young planting in the way, because the tractor can't go anywhere else because there's a huge ditch or there's this archaeological feature, and it ends up just getting driven over. It happens so often. And that picture's off the map. But this is kind of what they look like on the ground. Some of you will have walked around and you'll see the double blaze of blue. That's what that is. That's telling the machine driver to go there. And I like to call it the equivalent of keyhole surgery. So down that one little track, about 50 tons of woodland has been taken off of 50 metres from the right, 50 metres to the left, done at the right time of year, and you can see where it's gone. But in modern day practice, it's doing okay. Okay, to the next big subject. So we can't get Hardwick's woodlands to be this fully functioning, near natural woodland by planting alone. We've got to get some of our natural regeneration established in a way. And a big thing of that is climate change. There's a lot of studies now about looking into how the health of a tree, even when it's 40, 50 years old, whether it started from being a naturally generated seedling or a planted one. And naturally regenerating trees that have got there under their own steam are fundamentally more healthy. And the other thing they can do, in quite short time spans, they can adapt, particularly to climate change. So it is crucial that we start getting natural regeneration away. And these pictures kind of show the issue. And again, the issue is actually across the whole of the UK. Different deer species in different places, but the southeast has a particular problem. This was an experiment not very far from here, but 35 miles away. The two pictures are the same woodland. It was a Forestry Commission site. They put a deer fence around it and left it for 15 years or so. And that's the picture in the top left. They then took the fence down, and within 6 years, it looked like that. So the deer had gone through and not just eaten everything that they could, the next picture shows it, but they rubbed through the bark and break the trees down. And I think this was actually an ancient woodland site, but if we go back to what's precious about ancient woodland, it's what's in the soil. And here you can see it's gone from, you know, a sort of very varied, healthy woodland floor to being dominated by grasses. And this is really bad, because once you start getting grasses to dominate, you don't have bare mineral soil. And most trees, unless they're like a big acorn or something that's buried by a mammal, most tree seed needs bare mineral soil to naturally generate. If they hit grass, they'll just dry out and die. And so yeah, on Hardwick we've got 3 main deer species. The only native one, the roe, isn't that much. They're here in too high numbers really, but they aren't that much of a problem. They're the native one. Woodland since the Ice Age and roe deer pretty much developed together. They're very sort of casual graziers. They won't go and do this sort of damage, and they won't just go into one area in a huge herd and sort of act like cattle. Whereas fallow definitely do that. We've got enormous herds of fallow to the northeast around Benson. The last time it was counted, there's one herd of 170. And they move and they'll go into a woodland, and within 2 days it can look completely different. And then the next, or as much of a problem, are muntjac. And muntjac are really weird. They're not really a deer. They're not a herd animal. They're nocturnal, and they're territorial. And they have these horns that constantly grow, and their scent marks are on the velvet on their horns. So they, you know, like a roe deer or a red deer might do this to one tree a hectare. And it's saying, look, I'm the buck, I'm here, go away. Whereas muntjac, their areas can be down to half an acre, a quarter of an acre, and they will do that to every tree in their little patch. And if you wander off the paths on Hardwick and start getting down on your hands and knees and start looking at all the regen, 99% of it has got that on it. Where a muntjac's gone, this is my area, and I'm just going to put my markings on every single tree. And that sort of damage is pretty terminal really to tree health. It will encapsulate, it will grow, it will get a bit bigger, and a wind event will come along and it will blow down. And specifically if we're talking about, you know, high forest structures, we need big healthy trees. We can't have this on the base of every single one. And then these guys. Grey squirrels introduced actually longer ago than you would think, 1870. But they took sort of 40, 50 years to really get established. And then from the 1960s, it was fairly evident, particularly in the southeast, what was going on. All of the southeast has been at peak grey squirrel populations for about 30, 40 years now. The broadleaf woodland can have up to 1,100 a hectare. Phenomenal amounts. And so linking back to our geology at the start with these thin chalky soils, we're really limited on the sides of the Chiltern Hills with what we can grow, and that's hence why there's a lot of beech. ash is sort of for probably the next 50 years a little bit out of the question, and it was somewhat immune to grey squirrel damage. But everything else, oak, lime, each cherry to some large degree, they're all really, really, really vulnerable to grey squirrels. To the point where all of this sort of under 30% of Hardwick's woodland that we've had to cut down and regrow, now that they're established, particularly the first few years of our ash dieback programme, all those trees are getting into that age cohort where these guys are just going to go through and they'll just strip everything. And then going back to that first slide where it was showing the year breakdown of Hardwick's standing trees, the planting year, everything since 1980 we've lost. There was a lot of planting of beech, which questionably wasn't particularly well thought out, but in the 80s and 90s, and all of that we're just having to put big mulchers in. There's not even a single bit of firewood we can salvage from it. And that's, some of those little areas of beech plantings are 35 years old. In the 35 years it's not even grown a bit of wood that tall, that round, because they're just constantly getting eaten. I'm quite excited. From January 2024, we've secured quite a lot of funding to pay somebody full time to manage squirrels on Hardwick, and hopefully we can get some. So going back to why Manage Woodland, hopefully some of that's a bit more evident. I wanted to use this slide to sort of think about the national picture about woodlands generally. There's a crazy statistic. The UK is the second biggest importer of timber in the world, and that is not per head of population. That's as a tiny little country with generally good soils and a temperate part of the world that can grow trees really well. We're the second biggest importer of timber, second only to China. It's quite mad. And then obviously thinking nationally, decarbonising construction, steel, concrete, very, 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 very carbon intensive. We need timber to replace that. And then there's a big thing which is what I'm really passionate about. The UK has some of the strictest laws around woodland management in the world. And it's a shame that our imports are so high, because we're exporting our problem. We're importing trees from other parts of the world that probably aren't getting replanted or managed in particularly good ways. So managing our own woodland is fundamental to them, because what our woodlands are plantations across the board generally, but also for the world. We can't sort of export our duty to not be doing good woodland management. And then that last point, there are tiny remnants of rainforests, wet rainforests in the west coast of Scotland. Everything else in the UK, even though we will give it a classification of ancient woodland, what that means is it was a woodland from 1600, pre-1600. But when you go to those sites now, and some places that it's not this case, and there's often a lot of old growth features there, but there's been so much intensive management of those sites. So this idea that there's sort of perfect woodland out there in the UK, where we can just sort of let it do its own thing, doesn't really exist. And if it did, and there are places where it does, obviously things like grey squirrels and deer, grey squirrels which we've imported, and deer which we've also imported or allowed to become incredibly high numbers of, because we've taken away wolves and their natural predators. We're an intrinsic park. We've done so much activity on this island that it's fairly fundamental that we manage it. Questions?
Would you like questions in the light?
Yeah.
When you say this, the answer's in the soil, you say some of the ancient woodlands in the soil, does that mean that left alone it would come back up again?
Yeah, in a lot of places, yeah. If we can keep the deer off of it.
Yeah.
And you can see, so I don't know if you have you spotted when you go up Path Hill, on the left hand side there was some ash that got cut down.
Yes.
So there is actually. So that's an overview of Hardwick's ancient woodland or ancient woodland on planted woodland on ancient woodland sites. And just off the map is where that ash was. And so we call that a secondary woodland site. Essentially, it was a field. We know the history. It was a field up until the sort of 1930s, I think. And then it was given up on. It was too steep, not very good. And then ash regenerated through it, and it kind of got away. Prior to cutting it down, you could go there in spring, and you could see where the old fence line was from when it was a field to the beech woodland. And in 100 years, or 110 years, not one single bluebell had moved a foot across from where that line was. So ancient woodland, it is phenomenally important. But yeah, the answer to it is in the soil. From that sort of hundreds and hundreds, thousands, tens of thousands of years of build-up of soil. So in many ways, sort of managing woodland on top of ancient woodland sites involves invigorating that, getting that back, giving it light, giving it diversity, giving it sort of different things.
I can just add a bit to that. So, because I managed coppice cycle woodlands, a lot of the ones I took over had not been cut since the war, and are now sort of 70 or 80 years old, and yet you can get 100 species coming up that have not been seen.
Yeah.
They have phenomenal longevity as seed, and that's why they've been selected for that rotation.
Yeah.
Although the past rotations were very short, much shorter,
but that's
and yet
it.
somehow the seeds are surviving even though we've changed the rotation length.
But to add to that, that's why the answer's in the soil. But if you think about all the other species that then follow on from that ground flora, they can't survive. It's amazing what sort of plant seeds can survive in the soil, dormant for 100 years. But all the butterflies, all the other invertebrates, all that other life that requires that, it can't wait that long. And that's partly why we've got this huge biodiversity crisis in the UK. And yeah, to add on to that, there was a famous site. The Woodlands Trust are a bit of a dirty word in forestry, because they had a policy from the 90s to have no intervention. And they had a famous site, you probably know it, James, in Kent, where it was famous. It was a coppice site. It was famous for loads of things, and it had a couple of red data book species. One of them was a bird. I can't remember what it was. But they allowed some research students to go there, and essentially over a decade they just watched it decline, and ended up concluding what we kind of know as foresters already, that it was because of a lack of management, which is why it went into that decline. It didn't have the coppice cycles, it didn't have the light coming in, it didn't have this ground flora proliferating, and so it didn't attract all the insects and all the birds. So it's a fascinating thing. Humans were in the UK at least, we're such an intrinsic part of what we think our nature is, because we've been so involved in how we've managed woodlands, how we've done it.
So in that case, were the trees not being affected by the deer and squirrels, or damaged and stunted? Because originally herbivores created coppice in continuous woodland by oryx with their big horns, and herbivores making clearings in the forest. So what in that case was did it go into decline?
Generally, I suppose the numbers were much smaller. So
but what kind of decline would you describe in that case, where they left it alone?
In the case of the deer leaving it alone.
The forest trust leaving.
Oh, I see. Because they weren't managing the woodlands, so they weren't doing any cutting. They were just letting this coppice grow and grow and grow, and eventually, the stools are rotting out. And because they didn't have these cycles of coppicing and getting the light back in, that's why it declined. And yes, had they carried on leaving it, you would have thought that sort of nature would take its course in due course, but unfortunately it doesn't, because we've got such high deer numbers, because we've got things like grey squirrels. That equilibrium can't come back, if I've answered your question.
Sort of, it's just a sort of a broader thing of this. The predator thing is a problem for numbers getting out of control, but as they've sort of evolved with woodland, the herbivores, the deer and squirrel, play their part in the ecosystem and making both clearings and succeeding woodland into new areas.
They have to some degree, yeah.
So if
I mean, things like squirrels aren't native at all, so they've never had their
the
problem.
red squirrels were doing the same before.
Yeah, but they don't do the damage. It's only greys that
Well,
strip
they
bark.
were also culled in the early 1900s for damaging bark of trees. There was a big cull of red squirrel.
Yeah, but not to anywhere near. There's the odd. In Scotland it still happens, and it's very specific, just in oak after really harsh winters and stuff like that. But it's nowhere near as sort of endemic as squirrel damage.
I mean, Highland martins would be the obvious thing.
Oh, absolutely. Yeah. I mean, the squirrel problem is come from a whole host of how we've managed. You know, I put the squirrel problem at the door of gamekeepers. Sorry if I've upset anyone, but you know, hundreds of years of killing everything that could possibly, and there were a lot. You know, polecats, pine martins, all our raptor species. We've done a lot to really put things out of whack. Yeah.
I wanted to ask, you said something about when you're harvesting you should leave some dead wood.
Yeah.
And could you just say why that was? I didn't understand.
I think, again, statistics, I should have these all written down. I think something like 90% of forest specialists species across the board require dead wood at some point in their habitat. Butterflies, bees, birds. So it's now, again, going back to sort of why UK forestry practice is some of the best in the world. We have to, under UK rules, something called UKFS, leave a certain amount of standing and fallen deadwood. So we don't harvest, generally we kind of only go down to that. And it can kind of sometimes look a bit messy, and we often go around, and I'll measure them now, but we need to sort of have a couple of cubic metres of standing deadwood a hectare as well, at any one given time. Just for the life cycle of everything in the forest.
Ben, so when we've got this continuous colour forest on Hardwick, all these different species at different ages and different heights, you're going to go in every so often and take out an individual tree here and there.
Yeah.
So how will you decide, you know, at what tree to take at what age? And are there some trees that you just will never cut down?
Yeah.
You want to have a tree that's hundreds of years.
Yeah,
And
absolutely.
also, how's that ever going to be economic when you're just doing individual trees in?
Good questions. So yeah, it becomes an individual tree selection system, and it gets quite complicated about what trees you select and when. But generally, you're guided by understanding your forest dynamics and then going for the big trees. It's quite counterintuitive to how we've managed woodland before. Up until now, foresters have always gone for the little suppressed tree, and then we cut it all down in one go. But instead, we need to completely, and it's hard, because even I was sort of trained in that, we have to completely reprogram ourselves and go, okay, this one's huge, what's the wind going to do? If I take this one, does it free up 6 or 7 other trees to then get to that size? So yeah, and then the other part of the question, absolutely, we will be leaving old growth features and then trying to develop old growth features, so having veterans within the stand, and then sort of accounting to create future veterans or landscape character trees. And then because so much of it's based on having the right species mix for the soil and natural regeneration in due course, obviously at the moment we're doing a lot of sort of heavy input of underplanting. We'll be leaving seed trees, so there will always be an amount of, you'll always leave a certain amount of oak per hectare so that you know you've got the seed going forward, for example. But yeah, it does become, it becomes complicated. But to answer the economics of it, again, I didn't actually put it in the slides, I probably should have. So for decades there's been an argument, and generally the argument over economics has been won by big industry who likes clear felling. And where this sort of, I should say, irregular continuous cover and continuous cover in general amounts for less than 1% of the management of woodland in the UK. And of that 1%, it's all in the southwest really, and Hardwick and Hatfield now. So there's quite a slow uptake, but the economics of it are really changing really quickly, and the best way to describe it is in the cost of re-establishing after clear fell. So quite a lot of you in here helped with the watering that we did in 2020. That was amazing. We saved loads of trees, but it did actually give us loads of real life data because there was areas that we didn't do. Often because there were a little bit and there was a huge group of 50 people and we wanted to keep it moving efficiently. But across the areas that we didn't water, and there's places where we did water, the trees that failed were those that were exposed out on their own to the elements. All the other saplings, even if they got water or not, and there was another sort of 10 hectares that we never got to water in, and the saplings that were under dappled shade had a 90% plus survival rate, opposed to those out in the open. And following last year's drought, the government had to find a whole load of money, God knows where they found it from, to pay landowners to replant, and they allowed it for 2 years prior to both restocking and particularly any sort of woodland creation grants. And I've got colleagues down in Hampshire who one of them did a 14 hectare woodland creation scheme and it all died. So £15,000 worth of planting just gone and they had to do it again. And the government shelled out. But that is very quickly becoming a reality in forest economics. And if you can develop a system whereby your underplanting and your regeneration is being looked after. I don't know if anyone knows Susan Simard's work, Finding the Mother Tree. Really worth looking up. I can describe it quickly, but she's a forester scientist in North America and did work using isotopes in trees, and she used alder, birch and Douglas fir on a stand, and essentially she found out at different points in the year between different species of all ages they were giving each other nutrients and resources. And I can't remember quite what, when and how, but essentially like in the spring the Douglas fir would give the birch some sugars because they're connected. There's a nice term for it, the wood wide web, but underground, the whole mycorrhizal fungi network, which we only know a tiny bit of. But yeah, all that stuff just gets ripped apart in a clear fill. So that's probably my best answer to the economics of it. The other side of it is that instead of growing loads of little matchsticks, you're growing big trees that are actually worth something. And to get to there, we have to change everything, particularly in the conifer side of things. Because at the moment, all of the mills in the country are programmed to take bits of wood no bigger than 50 centimetres. If you've got a cracking big tree, Norway spruce or Sitka spruce, and it's over 50 centimetres, you've got to cut everything off of it until you get to 50 centimetres, because the whole thing is so automated. And that's a big problem. We need to sort of change that in time.
Does a better managed woodland lead to a better quality of timber?
Yes, arguably, yeah. I mean, essentially when it comes to, the basics of managing woodland now, which are squirrels and deer, squirrels just completely trash all timber value. So yeah, if you're managing woodland, you're managing squirrels, and then your timber is much better quality.
But healthier tree,
Yeah,
probably better
Yeah,
structure of the
absolutely. Yeah, that as well.
timber,
Yeah.
so-
Slower grown generally, yeah, so sort of closer rings, yeah. Unfortunately, in this day and age, where everything's fast, really high quality timber is sort of, it's not a pillar of forestry as it should be. But I don't know, I think that will change in time.
When you're talking about managing squirrels and deer, what is it you're talking about? Is it killing? Is it
Yeah,
protecting the trees or
Cu-
establishing
Culling, well, both, but yeah, you can't do any protection of trees for squirrels. You can do some for deer. It's incredibly expensive and never particularly great for the tree. So all these stakes and tubes that we've got out there, loads of it's microplastics. We're going to have to spend a lot of money getting all that plastic back, and most landowners don't bother. It just breaks down. But because of the stake, the tree really relies on it, and it becomes quite infirm quite quickly. So yeah, it does means culling. At the moment, we have a cull total of deer on Hardwick at about 160, 170, all species. We're now contractually and legally obliged to more than double that from January 2024. So yeah. But just to sort of add to it, I've got two colleagues who, one's vegetarian, one's vegan, and they're strictly vegan, and all he'll eat is meat-wise is venison. which I don't know if you can kind of get into his mind and understand how he's justified that in his mind. I think you can, essentially things like squirrels. I would much rather we try to address the imbalance of predators for those, and we can reintroduce pine martens. There's a lot of science coming out now about goshawks and what they do, and they predate predominantly in squirrels. In Gloucestershire, there was a really good project recently and found that a goshawk's diet was 80% squirrel. Unfortunately, with deer, where's our shepherd? What do you think about wolves? I think you have hard enough. Yeah. I think you might be the only shepherd saying that.
Yeah. Now I realise that with the fox, I'm not going to kill the fox either.
Luckily we don't. We've got the stalkers not to kill foxes anymore. But yeah, with deer, it's a harder nut to crack when it comes to sort of readdressing the balance out there.
But at least they're edible.
They're really edible. We also need to do a huge PR campaign on venison. It is the most free-range, organic, healthy, abundant meat source on our doorstep, and we're importing meat grown on rainforest land in South America. And people think that venison's posh. I don't get it.
You asked Pete James on protein production.
It's an interesting challenge. James.
You said there's very little continuous cover forestry, like 1%. When I was at agricultural college in the late 70s, we were taken to the Bathurst estate, which you probably know of, around Cirencester, very big wooden estate. And I'm about 95% sure that they were talking about continuous cover forestry. I've remembered that all these years.
Yeah.
Or something resembled it. They talked about varied age woodland. So has the idea existed even in Britain? For a long time?
The idea's existed. It's mainly been championed by the Swiss and the French, and to some degree the Germans. But particularly in Switzerland, there was a guy called, I can't remember his name, it's also Swiss, but sort of from the mid-50s. And when it comes to irregular, all the methodology that you were asking about, Alistair, what trees to take when, all this terminology, it's sort of translated from the French and the Swiss. All the textbooks for that are from the French and the Swiss. The idea's been around, but the practice has never really got under steam.
French forests are just fantastic.
It's interesting, for CCF they've got it a little bit easier. Generally in France the soils are a bit more acidic, and so when they do operations sort of to manipulate the forest floor and get natural regen going, their windows are more open. Generally in the south of England, forest soil, certainly the humus layer is really fertile, and it can close over quite quickly. But the idea has been around a while, but certainly in practice, it's not massively there. Certainly in the UK.
How long do you have a sort of target date by which you hope to get all the forests how they should be?
Good question.
Is it?
I haven't thought about it, to be quite honest. Up until now, with that slide of the last 10 years, we've been firefighting. So 10 years ago we were looking at, let's do something with the beach, we really need to, God, what if something came along and there was a disease for beach? And there is actually a disease for beach in the continent. Also we know the closest stands that we have in the UK, so particularly beech on chalk in the Chilterns, the nearest equivalent on the continent, there's in northern Germany, there's quite a lot of very similar forests. And in the last 10 years, the climate change has ripped through them. Huge, not related to a disease. We know from the droughts in 84 and then 92, I seem to remember, in the UK, there was a lot of science done on the susceptibility of beech to water stress, and obviously drought. And it's really vulnerable. It's really vulnerable. I don't have a timeline. As much as we can, the biggest constraint is actually labour. There's a huge skill shortage in forestry across the board, from managers down to people working on the ground throughout the whole sector. To the point where our institute, the Institute of Chartered Foresters, has sort of essentially made itself a completely one campaign policy of just shouting about we need more people to get into the industry. So that's my biggest constraint is skilled labour. Now markets have sort of settled down, and that's only been really recent. In the sort of mid-2000s, it was still costing more to do the work. You know, so essentially, if you cut some trees down and got them to roadside, up until sort of 2000 something, it cost more to do that in hardwood generally than you got for selling it.